Welcome as we continue this series of videos for Houston Baptist University's College Algebra course. Today's topic deals with rational expressions and rational equations. Notice the word ratio at the beginning of the word rational. A rational expression is a ratio, or in other words, a fraction, with a numerator over a denominator. The numerator and denominator can be numbers or algebraic expressions. Many students are uneasy at the very mention of the word fraction, but I hope to show you in this video that a couple of special properties of the number 1 make working with rational expressions and equations easy to understand. In fact, in mathematics, we really need to think about special properties of the numbers both 0 and 1. We'll need to understand these properties in order to work with the rational expressions and rational equations. What are the special properties of 1 that I'm talking about? Well, for any expression n times 1 equals n. And for any non-zero n divided by n equals 1. This is common sense. We all know that 5 times 1 is 5, 6 times 1 is 6, 5 divided by 5 is 1, 6 divided by 6 is 1. It seems simple, and it is. The neat thing is that these simple properties of the number 1 will be the key to working with rational expressions and rational equations. Before we try to add 2 rational expressions, let's take a little side note and talk about money. If you want to add 2 nickels to 1 quarter, of course, you cannot just add 2 plus 1 to get 3. You first have to convert to a common name. 2 nickels plus 1 quarter is the same thing as 10 cents plus 25 cents. Notice that we've taken 2 different names, nickels and quarter, and converted to a common name, cents. Now that we have the common name, we can just add the numerical parts. 10 plus 25 is 35. So 10 cents plus 25 cents is 35 cents. What you say does that simple illustration have to do with working with rational expressions? Well, similarly, to add 2 fractions, you first have to get a common denominator. If you look at the middle part of the word denominator, nomen comes from the Latin word for name. So a denominator is the name, and to get a common denominator, we're going to use the special properties of the number 1 that we've just been talking about. Let's take a simple arithmetic example before we try to do algebra. Suppose you want to add 2/3 plus 1/5. The first step is to use the special property of the number 1. I can rewrite 2/3 as 1 times 2/3. And I can rewrite 1/5 as 1 times 1/5. In the next step, I'm going to use another special property of the number 1. I'm going to rewrite 1 as 5 divided by 5. And I'm going to rewrite this other 1 as 3 divided by 3. Why would I do that? Well, to multiply fractions, you multiply the numerators and multiply the denominators. So 5/5 times 2/3 would give me 5 times 2 is 10 in the numerator, over 5 times 3 or 15 in the denominator. The second product would give me 3 times 1 or 3 in the numerator, and 3 times 5 or 15 in the denominator. So by using these special properties of 1, I now have a common denominator. All I have to do is to add the numerators and put it over the common denominator. 10 plus 3 is 13, and my common denominator is 15. That's a simple arithmetic problem, but I promise you the algebra that you're going to be doing is really no harder than that. The exact same principles work when adding algebraic rational expressions. Let's take this example. Suppose I want to add 2x over x minus 1 plus x over x minus 2. All right, as our first step, let's use the special property of 1. I will multiply each of these two algebraic fractions by 1. And then as the next step, I'm going to rewrite the first one as x minus 2 over x minus 2. And I'm going to rewrite the second one as x minus 1 over x minus 1. The new denominator is going to be x minus 2 times x minus 1 for both of these fractions, giving me a common denominator. The numerator would be the product of x minus 2 times 2x added to this product of x times x minus 1. To finish the problem, I simply multiply out the numerator. X times 2x is 2x squared, minus 2 times 2x is minus 4x. And then I'm adding x times x is x squared, and x times minus 1 is minus x. Finally, I simplify the numerator. 2x squared plus x squared is 3x squared, minus 4x minus another x is minus 5x. And that numerator goes over the common denominator. You can see that we use the same properties of the number 1 to add these algebraic fractions that we use to add the arithmetic fractions. Now, what happens if we're trying to solve an equation that has rational expressions? Let's look at this example. 2x over x minus 1 plus x over x minus 2 equals 3. Since we now have an equation, not just an expression, we can multiply every term on both sides of the equation by the same expression. If we multiply through by the least common denominator, we clear the fractions because of the special properties of the number 1. Here was the example we said we wanted to look at. 2x over x minus 1 plus x over x minus 2 equals 3. Remember, we said that we want to multiply every term on both sides of the equation by the common denominator. The common denominator here would have to be the product of x minus 1 times x minus 2. So we've multiplied the first fraction, the second fraction, and we've multiplied the 3 on the other side of the equation, all by the same expression, x minus 1 times x minus 2. Now, think about the special property of the number 1. X minus 1 over x minus 1 equals 1, and x minus 2 divided by x minus 2 also equals 1. When we have a factor of 1 in our multiplied product here, we do not change the product. So 2x times 1 times x minus 2 is just 2x times x minus 2. X times x minus 1 times 1 is just x times x minus 1. And on the other side of the equation, we still have 3 times x minus 1 times x minus 2. You can see that we've used the special property of the number 1 to clear the fractions from our original equation. And now it's easier to solve the problem. I'm simply going to multiply out 2x times x is 2x squared. 2x times minus 2 is minus 4x. X times x is x squared. X times minus 1 is minus x. The x minus 1 times x minus 2, if you FOIL that, is x squared minus 3x plus 2, and that's all multiplied by 3. 2x squared plus x squared is 3x squared, minus 4x minus x is minus 5x, and distributing the 3 on the other side gives 3x squared minus 9x plus 6. If I subtract 3x squared from both sides of the equation, I'm left with minus 5x equals minus 9x plus 6. Adding 9x to both sides of the equation gives me 4x is 6. And dividing by 4 gives me x is 6/4, which is the same thing as 3/2. Now, before we go further, we also need to look at the special properties of 0. For any expression in n times 0 equals 0. For that very reason, we can never divide by 0. Why, you ask? Well, think about it. We say that 6 divided by 3 is defined to be the unique number 2 because 3 times 2 is 6. But there's no number that could equal 6 divided by 0 because 0 times any number could never equal 6. 0 times any number is 0. Also, 0 divided by 0 could never be defined as a unique real number because 0 times any number is 0. This means that whenever you encounter a rational expression in algebra, any variable in a denominator can never equal a value that would make that denominator to be 0. You are never, ever allowed to divide by 0 in mathematics. Therefore, when you multiply every term of an equation by an expression containing a variable, it is possible to introduce an extraneous solution that does not satisfy the original equation. Any result that would make one of the denominators in the original equation equal to 0 would be extraneous and must be rejected. Let's look at an example. Take the equation x plus x over x minus 2 equals 2 over x minus 2. We want to clear our fractions by multiplying every term on both sides of the equation by the common denominator x minus 2. So I'm going to have x minus 2 times x plus x minus 2 times x over x minus 2. On the right-hand side of the equation, I'm going to have x minus 2 times 2 over the denominator x minus 2. Again, I use the special property of 1, that x minus 2 divided by x minus 2 is just 1. So that cancels, and I'm left with x times x minus 2, which would be x squared minus 2x, plus this x equals, on the right-hand side, I'm left with just 2 times 1, which is 2. Minus 2x plus x is minus x. If I subtract 2 from each side of the equation, I have the quadratic equation, x squared minus x minus 2 is 0. That can be factored as x minus 2 times x plus 1 equals 0. Now, another special property of 0 concerns the fact that anytime a product equals 0, at least one of the factors has to equal 0. If x minus 2 equals 0, x would equal 2. If x plus 1 equals 0, x would equal minus 1. But wait, 2 has to be rejected. It's extraneous. It's not a true solution. Why? Because if you substituted 2 for the x back in the original equation, you would have a 0 in the denominator. And remember, you can never divide by 0 in mathematics. So we say that 2 is rejected as being extraneous. It's not a true solution. The only solution to this equation is x equals minus 1. I hope this helps and helps you to realize that working with algebraic fractions is not so scary after all. I think with a little practice, you'll be very comfortable with solving some rational equations from this part of the textbook.